Okay, hello everybody. So today is going to be the last video that you're going to see on Chapter 6, Sections 3 and 4. And I'm going to show you how to deal with systems where neither one of the coefficients are the same, and you end up having to multiply the system by both of the equations by a number to get the numbers the same, so you can use the process of elimination to solve the system. So as you remember, hopefully from the last video, we had systems where one of the equations had to be multiplied by a number in order to get both of the coefficients to be either the same or opposite signs. So whenever we added them or subtracted them together, they cancel. Now, sometimes you will get systems where both of the equations need to be multiplied by something. And so what you have to think about and what needs to keep kind of in the back of your head is what, if you remember back from quite a long time ago, is called a least common multiple. And so you need to find a least common multiple between the two numbers to figure out what we should turn the equation into so they cancel. So as an example, the least common multiple of 4 and 5 is 20. That's a pretty big number. If you look at the least common multiple of 2 and 3, it's going to be 6. So out of the two options, I'm going to actually make the y's be the same because the least common multiple is a little bit smaller and we'll be dealing with smaller numbers. So what we need to do is we need to turn this 2 into a 6. The way that we're going to do that is we're going to multiply the entire equation by 3. So the 3 is going to distribute to the 4x, it's going to distribute to the 2y, and it's going to distribute to the negative 14. And when we do that, we end up with a new equation. That equation is 12x minus 6y, plus 6y, and that equals negative 42. Okay, so each one of the terms in that equation got multiplied by 3. So we created a new equation. Now the next one I'm going to multiply by, I want to turn this 3 into a 6. In order to do that, I need to multiply it by 2. So this whole equation is going to get multiplied by 2. So when I do 2 times 5x, and then 2 times 3y, and then 2 times negative 17. So 2 times 5x is 10x. 2 times 3y is 6y. And then 2 times negative 17 is negative 34. Okay. Now, what I want you to notice, why did we do this? Well, we are trying to use elimination to solve this system. And elimination requires that one of the variables goes away. And the only way to get it to go away is if they are the same number. And if you notice, because we multiplied the first equation by 3, and we multiplied the second equation by 2, we created 2 new equations that both have a 6y. That's good, because now what we will do is we will simply subtract the 2, just like this. So we're going to do 12x minus 10x. That gives me 2x. I'm going to do 6y minus 6y, and that's 0. Those go away. That's good. That's what we want to happen with elimination. The last step is going to be negative 42 minus negative 34. So when we do that, when we have actually minus negative, and I'll even write this down, negative 42 minus negative 34, that's actually going to turn into negative 42 plus 34. Okay, what we end up with there is negative 8. So now to solve this, we're going to divide both sides by 2. And we get x equals negative 4. And there is my first value. We do need to get the y. And as we've done in all the previous videos, in order to get y, you need to substitute the x back into one of the equations. In this case, none of the equations are already solved for y, so it really doesn't matter what you substitute the negative 4 in for. I'm probably going to use the first equation. So we'll have 4 and then x plus 2y equals negative 14. And in place of that x, I'm going to write a -4, just like that. And then I'm going to follow PEMDAS. Well, not really PEMDAS, but I'm going to multiply first. So I'm -16 plus 2y equals -14. I'm going to add 16 to both sides. And I get 2y is equal to 2. And then when I divide both sides by 2, I get y equals 1. There's my other value. And so we will list those values as xy. So -4, 1. So what that means is if you were to graph both of these, remember, we're still dealing with linear graphs. These were both lines. If you graph them in a coordinate plane, they will cross in one place. They will cross at -4, 1. Now, I'm going to show you one more of these. It's going to be very similar to the last one. You're going to see there's a system, and neither one of the x or the y variables are the same right now. So we need to figure out what is the least common multiple of either the x's or the y's. So if I'm looking at the x's, the least common multiple of 2 and 5 is 10. The least common multiple of 3 and 5 is going to be 15. So I'm going to go ahead and go with the first one. I'm going to eliminate the x's first. So to turn a 5 into a 10, I'm going to multiply by 2. So this 2 will distribute to each one of these numbers just like this. So I get 10x minus 6y equals 12. Right? So I distributed the 2, 10x minus 6y equals 12. Now we are turning the x's into 10, which means the second one needs to be multiplied by 5. Just like that. Okay? So 5 times 2x is 10x. 5 times 5y is 25y. And 5 times -10 is -50. Now, what do we do? Do we add or subtract? Well, you have to look at the variables and see what we have. If they're the same, which they are in this case, if we added that together, it would turn into 20x. That's not helping us. It's not getting rid of anything. So we are going to subtract these. 10x minus 10x is 0. That's what we want to happen. We have -6y minus 25y. That turns into -31y, just like that. And then we have 12 minus -50. The minus negative becomes plus, and so it becomes 62, just like that. We're going to divide both sides by -31, and y equals -2. So there is what we get for y. Now, it doesn't matter which variable we solve for first. We can solve for x first, we can solve for y first. Doesn't matter, because once you solve for one, you're going to use that variable and plug it back in to get the other variable. So we do still need to get the x. I'm going to go ahead and use the first equation. We have 5 times x minus 3 times y equals 6. Now, in place of the y, I'm going to write -2. And then we're going to multiply. So 5x and then -3 times -2 is +6 equals 6. I will then subtract 6 from both sides, and I get 5x equals 0. And then when I divide both sides by 5, x equals 0. So there's my other value. I've got my x, I've got my y. I'm going to write those as an ordered pair, 0, -2, and I'm done. Got my solution. So again, same as the last one, this system, if you were to graph it, it would cross in one place, and it would cross at the point 0, -2. So there you go, guys. There are all the different kind of types of systems that you'll run into with elimination. And as always, if you have any questions on this, please feel free to email me. Have a great day.